Hello, my dear students. Today we are going to continue chapter 1, which is transition metals. We are going to discuss the properties of iron, physical and chemical properties. Then we are going to discuss the types of iron oxides and their preparation and their chemical reaction. So let us start. Now we are going to discuss the iron oxides. The first oxide we are going to discuss is iron 2 oxide FeO. The preparation of iron 2 oxide from heating iron 2 oxalate in the absence of air, as the equation proceeds on the screen, it gives iron 2 oxide and the carbon monoxide gas and the carbon dioxide gas. And so we have give reason in this point. Heating iron 2 oxalate gives iron 2 oxide, not iron 3 oxide. The reason for that is the produced carbon monoxide gas is a reducing agent that prevents the formation of iron 3 oxide. The second point for preparation of iron 2 oxide is the reduction using reducing agent as hydrogen gas or carbon monoxide gas. So, if we reduce iron 3 oxide Fe2O3 by hydrogen gas at temperature 400 degrees Celsius till 700 degrees Celsius, it gives iron 2 oxide and releasing water vapor. But when using magnetic iron oxide Fe3O4 and reduced by hydrogen gas, also from 400 till 700 degrees Celsius, it gives iron 2 oxide releasing water vapor. My dear student, you can use hydrogen or carbon monoxide for these reduction processes. Now we are going to discuss the properties of iron 2 oxide. It is black, solid, insoluble in water. It reacts with dilute acids to give iron 2 salt. As the reaction proceeds now, when the iron 2 oxide reacts with dilute hydrochloric acid, as the equation shown on the screen, iron 2 oxide plus hydrochloric acid, which is dilute, it gives iron 2 chloride and water, which is iron 2 salt, is formed by adding the iron 2 oxide to any dilute acid. So, if we make the reaction between the dilute sulfuric acid and iron 2 oxide, it also gives iron 2 salt, which is iron 2 sulfate and releasing also water. Now we are going to discuss the oxidation of iron 2 oxide. When heating iron 2 oxide in air, it gives iron 3 oxide. Now we are going to discuss the reduction of iron 2 oxide. When reacting iron 2 oxide with reducing agent as carbon monoxide or hydrogen gas above 700 degrees Celsius, it gives iron releasing carbon dioxide gas. Or we can use hydrogen for the reduction as shown on the screen, FeO plus H2, also above 700 degrees Celsius, it gives iron releasing water vapor. Now we are going to discuss the second type of oxides, which is iron 3 oxide, Fe2O3. The preparation of iron 3 oxide by heating iron 2 sulfate. As the equation proceeds on the screen, on heating iron 2 sulfate, FeSO4, it gives iron 3 oxide and sulfur dioxide gas and sulfur trioxide gas. So we have give reason in this point, my dear students. Heating iron 2 sulfate gives iron 3 oxide, not iron 2 oxide. The reason for that, because the produced sulfur trioxide gas is oxidizing agent that prevents the formation of iron 2 oxide. Now we are going to discuss the second way for preparation of iron 3 oxide, which is done by heating iron 3 hydroxide. As the equation proceeds on the screen, on heating iron 3 hydroxide that has reddish brown color above 200 degrees Celsius, it gives iron 3 oxide and water vapor. My dear student, notice that when iron 3 chloride reacts with sodium hydroxide or ammonium hydroxide, it gives reddish brown precipitate of iron 3 hydroxide as shown on the following animation. When adding sodium hydroxide to iron 3 chloride, it gives iron 3 hydroxide that on heating it can give iron 3 oxide that we want to prepare. As the equation proceeds on the screen, if the reaction done with sodium hydroxide, iron 3 chloride plus sodium hydroxide, it gives iron 3 hydroxide and sodium chloride is produced. Or the reaction with ammonium hydroxide or ammonia solution, iron 3 chloride reacts with ammonium hydroxide, giving iron 3 hydroxide, releasing ammonium chloride. Now we are going to discuss the properties of iron 3 oxide. It occurs as hematite and it is insoluble in water. It is used in red pigments in paints and reacts with hot concentrated acid to give iron 3 salts. So, my dear students, we can differentiate between iron 2 salts and iron 3 salts, and also we can differentiate between the iron 2 oxide and iron 3 oxide by the reaction of the iron oxide with acids. Here the reaction of iron 2 oxide and iron 3 oxide with dilute acids, only iron 2 oxide dissolve and react, while iron 3 oxide doesn't react, as it reacts only with hot conc acids. As the reaction here on the screen, the reaction with hot conc hydrochloric acid with iron 3 oxide, it gives here iron 3 chloride and water is produced. Also reacts with hot concentrated sulfuric acid. Here iron 3 oxide reacts with sulfuric acid by heating and concentrated. Here it gives iron 3 sulfate and water is produced. So my dear students, iron 2 oxide reacts with dilute acids, while iron 3 oxide reacts also but with concentrated acids, and this is done by heating as shown on the screen. The reduction of iron 3 oxide. Here where iron 3 oxide reacts with carbon monoxide from 230 till 300 degrees Celsius, it gives magnetic iron oxide and releasing carbon dioxide gas. Here the reduction takes place from 230 till 300. But when the reduction takes place from 400 degree till 700 degrees Celsius, the product is be different. Here it gives iron 2 oxide and water vapor. So the reduction of iron 3 oxide depends on the temperature. When 230 till 300, it gives magnetic iron oxide, but from 400 degree till 700 degrees Celsius, it gives iron 2 oxide as shown on the screen. If we make the reduction of iron 2 oxide, Here above 700 it gives iron and carbon dioxide gas. Now the third type of oxide, which is magnetic iron oxide, that has chemical formula Fe3O4. Here the preparation, it takes place by passing air over red hot iron. As the equation proceeds on the screen, iron plus oxygen, it gives Fe3O4, which is magnetic iron oxide. Also, we can prepare magnetic iron oxide by passing steam over red hot iron. As the equation proceeds on the screen, iron plus water vapor, 500 degrees Celsius, it gives magnetic iron oxide and the hydrogen gas is produced. Another way for preparation, by reduction of iron 3 oxide, Fe2O3 plus carbon monoxide or hydrogen gas from 230 degrees till 300 degrees Celsius, it gives magnetic iron oxide and carbon dioxide gas. Now we are going to discuss the properties of magnetic iron oxide. It has magnetic property. It reacts with hot concentrated acid, giving iron 2 salt and iron 3 salt. So when we prove that the magnetic iron oxide is a mixed oxide, that you are going to do is to write the equation between the magnetic iron oxide and the hot concentrated acid, as it gives iron 2 salt and iron 3 salt. This equation proves that the magnetic iron oxide is a mixed oxide. Iron 2 oxide and the iron 3 oxide is mixed together. And so, my dear student, we can use this equation also to differentiate between iron 2 oxide and magnetic iron oxide. That reaction of dilute acid with iron 2 oxide only, but magnetic iron oxide does not react with dilute acid. Here the equation proceeds on the screen when reaction of hot concentrated hydrochloric acid with magnetic iron oxide. It gives iron 2 chloride and iron 3 chloride and water is produced. And also when reacts with hot conc sulfuric acid, it gives also iron 2 sulfate and iron 3 sulfate and water is produced also. So the reaction of magnetic iron oxide either with hydrochloric acid or sulfuric acid, it proves that magnetic iron oxide is mixed oxide. Why? Because it gives iron 2 salt and iron 3 salt at the same time. The oxidation of magnetic iron oxide. When heating magnetic iron oxide in air, it gives here iron 3 oxide. The reduction of magnetic iron oxide, Fe3O4 plus hydrogen, by heating from 400 degrees till 700 degrees Celsius, it gives iron 2 oxide and water is produced. Here, my dear student, if we use hydrogen gas for the reduction above 700 degrees Celsius, it gives iron and water. So the reaction here gives iron as the reduction takes place for magnetic iron oxide. Now we are going to discuss some questions. First type of question, write the names and symbols of the compounds indicated by letters from A to K in the following diagram. As the diagram shows here, symbols A, B, C, D, E, F, G, H, I, J, K. We are going to know these symbols, what is the formula of these compounds. So we are going to start with the compound A. As shown on the screen now, iron reacts with oxygen or water by heating. It gives here magnetic iron oxide, Fe3O4. To know the compound B, we know that heating iron to carbonate or heating iron to oxalate, in the absence of air, it gives here iron to oxide. Remember, my dear student, iron to oxalate is heated in the absence of air, with no air. But if it is heated in air, it gives iron 3 oxide as the oxidation of the produced iron 2 oxide. But here, both of iron 2 carbonate and iron 2 oxalate, when heating to give the same compound, here is the reaction of iron 2 oxalate when without air, heating of it gives iron 2 oxide and the carbon dioxide and the carbon monoxide gas. To form compound C by oxidation, it gives here iron 3 oxide. When reaction with sulfuric acid to give compound D, so it gives iron 3 sulfate. That reacts with ammonia solution or ammonium hydroxide, it gives here iron 3 hydroxide that has reddish brown color. Here, when iron 2 oxide reacts with dilute sulfuric acid, it gives here iron 2 sulfate. And then, when iron 2 sulfate reacts with sodium hydroxide, it gives iron 2 hydroxide. And here, my dear student, if you look to the next compound that we're going to know its chemical formula, we talk about the H symbol in the above of the screen. Iron with dilute sulfuric acid, it gives iron 2 sulfate that reacts with sodium hydroxide, giving iron 2 hydroxide. On the next side here, to form compound J, iron reacts with chlorine by heating. It gives iron 3 chloride that reacts with ammonia solution or ammonium hydroxide. It gives iron 3 hydroxide that you know it is reddish brown percepted. Next type of question is choose the correct answer. First point, when magnetic iron oxide reacts with hot concentrated sulfuric acid, what is produced? Is it iron 2 sulfate and water, iron 3 sulfate and water, iron 2 sulfate and iron 3 sulfate and hydrogen, iron 2 sulfate and iron 3 sulfate and water? If you think about it, my dear student, you will find the answer. It will be iron 2 sulfate and iron 3 sulfate and water, as the mixed oxide here forms two types of salts, iron 2 salt and iron 3 salt. Next point, on passing hot steam over red hot iron, it gives what and the hydrogen gas? Iron 3 hydroxide, iron 3 oxide, magnetic iron oxide, iron 2 oxide. If you think about it, my dear student, you will find that the answer, it will be magnetic iron oxide. Next point, when heating iron to oxalate in the absence of air, what is produced? Is it iron oxide, iron 3 oxide, iron 2 oxide? Said right. If you think about it, my dear student, you will find the answer, it will be iron 2 oxide. My dear student, remember that heating iron 2 oxalate in the presence of air, it doesn't form iron 2 oxide. It forms iron 3 oxide. But in the absence of air, it gives iron 2 oxide. Next point, when iron reacts with dilute sulfuric acid, iron 2 sulfate is formed, not iron 3 sulfate. As what? Iron 2 ion is more stable. The evolved hydrogen gas is reducing agent. Dilute sulfuric acid is an oxidizing agent. Iron 3 ion is not stable. If you think about it, yes, it will be the evolved hydrogen gas is a reducing agent. Next point. When heating iron 3 oxide with carbon monoxide gas at temperature 230 till 300 degrees Celsius is reduced to what? Iron 2 oxide, iron, magnetic iron oxide, iron 2 carbonate. If you write the chemical equation here, you will find that the answer it will be magnetic iron oxide. Next point. We can get iron 3 chloride by what? Reaction of dilute hydrochloric acid with iron, passing chlorine gas over red hot iron, passing hydrogen gas in iron 2 chloride, or passing hydrogen sulfide gas in iron 2 chloride solution. If you think about it, here's the answer. It will be passing chlorine gas over red hot iron. Next type of question is give reason for the following. Iron reacts with chlorine, giving iron 3 chloride, not iron 2 chloride, while it reacts with sulfur, forming iron 2 sulfide. The reason for that, because chlorine is a stronger oxidizing agent than sulfur, and the reason for that, as the chlorine has higher electron affinity than sulfur. Next point, iron reacts with dilute acids, forming iron 2 salts, not iron 3 salts. The reason, because the produced hydrogen gas is reducing agent that prevents the formation of iron 3 salts. Next point, iron reacts with concentrated sulfuric acid, forming both iron 2 salts and iron 3 salts. Because sulfuric acid is a strong oxidizing agent, giving both iron 2 and iron 3 sulfate. As the equation proceeds on the screen, iron plus sulfuric acid, concentrated and heated, gives iron 2 sulfate and iron 3 sulfate, and sulfur dioxide and water is produced. Next point, iron doesn't react with concentrated nitric acid. The reason for that, because of formation of non-porous layer of iron oxide, preventing further reaction with acid, as its molecules larger than the metal molecule, preventing the reaching of the acid to other molecule of the metal, so prevent further reaction. That's called passivity. Next point, pure iron has no industrial use, or not preferable to use iron in pure state. The reason for that, because it is relatively soft, which means low hardness, malleable, and ductile. My dear student, remember that manganese cannot be used as pure metal, as it is brittle, while iron can't be used as pure metal, as it is relatively soft. Next point, heating iron 2 oxalate gives iron 2 oxide, not iron 3 oxide, because the produced carbon monoxide gas is a reducing agent that prevents the formation of iron 3 oxide. Next point, heating iron 2 sulfate gives iron 3 oxide, not iron 2 oxide. The reason for that, because the produced sulfur trioxide gas is oxidizing agent that prevents the formation of iron 2 oxide. Next type of question. Write the scientific term for the following. The oxide formed when red-hot iron reacts with air or steam. Yes, the answer it will be magnetic iron oxide. Next point. The oxide formed when magnetic iron oxide is heated in air. Yes, if you think about it, yes, it will be iron 3 oxide. Next point. The type of iron oxide that reacts with dilute acids. If you think about it, yes, it will be iron 2 oxide. Next point. The type of iron oxide that reacts with hot concentric acid or hydrochloric acid or Heney concentrated acid, forming iron 2 and iron 3 salts. Yes, it is magnetic iron oxide. My dear students, we have finished our program today. I hope you understood all the points that we discussed today and the chemical reactions that we discussed today. So, till we meet again, my best wishes for you.